This video is going to be about polar coordinates. So in the past, we've only talked about Cartesian or rectangular coordinates, or at least that's what we've really focused on. So we've worked in the Cartesian or the coordinate or rectangular plane, and that's x and y, so that's where we're comfortable. And x and y works in a lot of situations, but there are some situations that are better suited for a different way of recognizing the coordinates. And so the other one is going to be using polar coordinates, and these are in terms of a radius and a degree measure. And so this is going to make more sense if we're talking about like the navigation of boats, or if we're modeling a gravitational field or something like that, where thinking about things only in terms of left and right and up and down doesn't quite make sense. Instead, it would be better to say how far you are from the center of a circle, basically, and then at what angle are you at in relationship to that. So when we're talking about polar coordinates, we can still kind of start, we're not going to call them an x and a y axis. We're going to call this center right here is called the pole. And we're still going to use kind of the positive x-axis, but we're going to call it the polar axis. And the reason we start there is because that's 0 degrees. So if we're starting, if we're using theta, or we're using degrees or angles to talk about the location of points, it would make sense that we're going to start at 0. All right, so if we look at this as r theta, and we're describing this, we're going to say that r is the radius, or it's the distance from the pole. And then theta is the angle formed by the polar axis and the ray from the pole to the point. And that may not make a lot of sense right now, so I'm going to go ahead and draw a little sketch here so you can see what we're talking about. So let's say the point that I'm going to be describing is right here. That's the point that I'm describing. So my first coordinate is the length from here to here. That's the r, so that's the distance from the pole. So I'm going to label that as r. And then theta, if we call this the ray and this is another ray, then the angle between these two rays would be theta. So that's all it's saying, is the angle formed by the polar axis. So right here there's the polar axis and the ray that goes from the pole to the point. So that's the other ray, and it's talking about the angle between those. So that's a formal definition. I think you guys probably understand exactly what that's talking about. Okay. When we are dealing with rectangular form, we typically plot the x first. We go left and right first, and then we go up and down. But in polar coordinates, we're actually going to find theta first. So find theta first. So we're going to look for our degree measure to start with. And then we go r units on that line. Now, there are two different ways you're going to see r values in these equations. One is a positive r value, so in that case you're going to move forward on the line for the angle. Or you could see a negative r value, and that means you're going to be moving backward. Now, we will be exploring this more as time goes on, but there's a special note that I want you guys to write, and this is even like circle this in marker or highlight it or make it big or something, but there are infinitely many ways to write every single point. And that's what makes polar kind of unique, is because if we're talking about rectangular coordinates and you have the point 2, 4, you pretty much only have the point 2, 4. But in rectangular, or in polar coordinates, that's not exactly how it works. So these are what the rectangular graphs look like. So you'll notice it kind of has the idea of a unit circle. So what I'm going to graph first is we're going to do the point 2 pi fourths. So if we're looking at this, first I need to locate where the angle is. And so I know that pi fourths is right up here, because this would be 0 and up here is pi halves. So I know pi fourths is right in between. So the first thing you do is you locate the line that has the angle you want. So this is the line that has the angle that I want. And then from the pole you go a distance of that radius there. So from the pole I count 1, 2, and then there's my point right there. Right? Now another way that I could describe that exact point is I could think about it as like going around the circle again. So if you guys remember this from our trig unit, we always had that idea of like plus 2 pi k. So on this one, I could add, let's see, so doing it in terms of fourths, 8 fourths would be 2 pi, so I could say that this could also be considered the point 2 and then 9 pi fourths. And that would be in the same spot, because it would be like I just went around the circle one more time. Or I could write this exact same point as 2, and I could be subtracting 2 pi, and so it'd be negative 7 pi fourths, and that would be exactly the same point. So again, the math that I did there is I started off with 1/4, and then I was thinking, oh, let's go around the circle, but end up in the same spot. And so that's the 9 pi fourths, and I could even keep going. So that would be 4 times 4, 17 pi fourths. So you can see all of these would be in exactly the same place. So there's a lot of different ways we could write this exact same point, just by adding 2, adding 2, adding 2, subtracting 2, subtracting 2, subtracting 2. Another way that we could write the point that's kind of interesting is using this idea that a negative r would move the point backward. So if you think about it, if I'm going to end up using a negative 2 in the point, then from the pole, like if I was on this line, from the pole, it would move it backwards, so it would move it over here. So if I wanted to come up with another way to write the point, then if I used this one over here, this would be 5 pi fourths, right? Yeah, 3 pi fourths, 5 pi fourths. If I wrote my angle as 5 pi fourths like this, then you would start over here at this line, but when it said to do a radius of negative 2, you would move backwards on the line, and so you'd end up putting the point right there. So right now, we have all 4 of these points give you that exact same spot on the circle. And now, of course, because we have this idea of adding 2 or subtracting 2 from the angle, we can find more points that are equivalent with this negative 2 right here. So I could say 5 fourths plus 2, and that would give me 13 pi fourths. Or I could have done 5 fourths minus 2, and that would give me negative 3 fourths. And all of those are exactly the same point. So I could plot all 6 of these at the same time, and every single one of them would be in that same spot. Alright, so we're going to write this down, kind of a shortcut's not the right word, but the pattern maybe, for thinking multiple points. So if you're starting with the same, I wrote 2, but I meant r. If you're starting with the same r value, then you take the degree measure that they originally gave you, or the radian measure in this case, and you can add and subtract 2 pi k. So add and subtract sets of 2 to get other answers. If you're going to use the opposite sign of the radian measure that they gave you, so when we went from +2 to -2, that's when we had to decide to use the angle on the opposite side of the circle, because if we use the angle on the opposite side and then have a radius that's negative, it bounces us back to the side that we really want to be on. So for us to get to the opposite side of the circle, we had to add pi. That's what gets us from pi-fourths over to 5 pi-fourths. So if we're changing the sign of our radius, then we're going to start with whatever they gave us to start. We're going to add pi. And then from there, to find a bunch of different answers, then we can add or subtract 2 pi from that number. And of course, this would work with degrees as well. So we're going to say plus or minus 360k. First add 180, and then you can add or subtract 360k. So that's the way you could think about finding lots of other points that are the same. All right, let's consider another point. I'm going to graph another one down here. So if I wanted to graph the point -3, 5 pi 6, here would be pi 6, 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6 is right there. So 5 pi 6 is along this line, so there's my angle, I've located it. Now because my radius is -3, I have to go the opposite direction. So I'm going 1, 2, 3. So that is the point for -3, 5 pi 6. Now you might be looking at that and you're like, that doesn't seem like it's on the 5 pi 6 line. That's because it doesn't really seem like it, right? It's got a radius of -3, so it went the opposite direction. So that point right there, if I want to label that point, I could call it +3. And if I call it +3, then I have to use this angle because the +3 would have come towards it. And this angle right here is 11 pi 6. So these two angles, or these 2 points I mean, are equivalent to each other. Right? And that's because if we started off with the regular r, which in this case happens to be a -3, then when we switch the sign for r, when we switch it from -3 and make it positive, we have to add pi to move it to the other side of the circle. So 5 pi 6, if I add pi to that, I get 11 pi 6. Okay. That might be kind of confusing. We'll practice it. I think that's one of the parts that's going to mess with your brain a little bit more in regards to this unit, but we'll get a lot of practice in. So the next thing that we want to be able to do is we want to be able to convert back and forth between rectangular and polar form. So before that, I'm just going to remind you guys of some math that we have done in the past. And it's when we were talking about the unit circle is when we did it. And we labeled a triangle like this using the unit circle, and we'd have a point up here on the unit circle, and we'd use that point as like x, y. And so this side of the triangle that you could make would be the x value, because that's how far to the right you go from the center. And then this side would be the y value, and the hypotenuse would be the radius of the triangle. So if you guys remember, if I want to figure out what cos theta is, I would say adjacent over hypotenuse, which is x over r. And in the unit circle, that was just plain old x, because the radius was 1, so it was x divided by 1. In this case, our radius is not necessarily 1, which is why I'm actually going to be leaving the r there. We also know that sine theta is opposite over hypotenuse, which would be y over r. So if I want to be able to get an x value, then x, when it's isolated, would be the same as the radius multiplied by cos of the angle. And the y value would be the same as the radius multiplied by sine of the angle. So, for example, if they have given us the polar coordinate 2 and then pi-fourths, which is what I gave you guys before, and we want to figure out what the coordinate would be in rectangular form, then all I have to do is plug it in here to find my x-coordinate, plug the information in here to find my y-coordinate. So for my x-coordinate, I'm going to say 2 times cos pi fourths. My y-coordinate is 2 times sine of pi fourths. And we're going to do a little bit of revisiting of the unit circle here. Cos of pi fourths, if you recall, is root 2 over 2. And so here those 2's would cancel, and we get that our x-coordinate is just root 2. And then over here, sine of pi fourths is actually also root 2 over 2. So the y-coordinate simplifies the same way. And so we're going to say that if you write this in rectangular form, then our answer would be root 2 comma root 2. And just like when we did the trig unit, anytime you recognize a value off the unit circle, then you should use the unit circle values to get something exact. If this had said like cos of 18 degrees, that's definitely not something on the unit circle, then you could plug it into your calculator and write down a decimal for me. Now, if we put this over here, and we...
Attention.
Sorry about that. So if we think about where this point would end up, it goes to the right 1, a little bit more than 1. It goes up a little bit more than 1. So the point, root 2 comma root 2, if you remember what the square root of 2 is, it's 1.41. And so that is exactly where this point would end up. So anytime you are making conversions, you can always check your answer to make sure that it's a logical answer before you commit to writing it down and saying that it's correct. Okay, so next we want to do the conversions from polar to rectangular. Nope, that's what we just did. I'm going to label that on here. I'm going to say polar to rectangular. So now I want to start with rectangular and convert it to polar. So if we're starting with rectangular, that means we're starting having the x values and the y values, and I want to figure out some way to solve for r, given my x and my y, and I want to find some way to solve for theta, given my x and my y. So if I had a right triangle and I have the 2 legs, then I'm going to say that using the Pythagorean Theorem is probably a great way to solve for r. So in this case, I could just say that r is the square root of x squared plus y squared. And if I have just the x and the y value and I'm trying to solve for theta, that's the opposite side and the adjacent side. So I'm going to say tangent of theta equals opposite over adjacent. And for me to get theta all by itself, I have to do tan inverse of y divided by x. Now with this part, you're going to have to be careful, because if you guys recall, when we do tan inverse to solve an equation, there's 2 spots on the unit circle that could be the answer, and so we're always going to have to consider what quadrant our point is in to make sure that we got the right angle measurement. So if we have the point 2, -2, and I want to figure out what the r value is, or the radius, I need to figure out how far it is from the center. And that's why you might recognize this kind of seems like the distance formula a little bit. So I'm going to say r is the square root of 2 squared plus -2 squared. And that's 4 plus 4, so this is just the square root of 8. And just like normal, anytime we have radicals that can be simplified, we're going to do that. And so the square root of 8 is 2 root 2. So that's my r value. For theta, I'm going to do tan inverse of -2 over 2. So right now I'm doing tan inverse of -1. And that is on the unit circle. And if you recall, that would be the x and the y divide together. They're the same thing. And -1, tan would be negative in quadrant 2 and 4. That's where y divided by x would be negative. And this picture, right 2 down 2, would be the quadrant 4 version of the angle. So for this one, we would say that theta is 7 pi fourths. 3 pi fourths would be tan inverse of -1 up here, but our point is in quadrant 4. So for this one, the polar coordinate would be 2 root 2 and then 7 pi fourths.